Hello viewers, welcome to Ekam Academy. Today, as part of our current affairs daily discussion, we are going to look into an issue called Ice Cube Neutrino Observatory that was recently in news. Upon some students' request, I have taken this topic for discussion in today's context. So the image which you are seeing on the screen, that is an ice cube neutrino observatory located in the southern pole, that is in Antarctica. So we'll understand what is the purpose of this observatory, what are the other observatories to observe neutrinos. We'll know what are neutrinos, what are the characteristics, and what are the origins of these neutrinos. Does India have any neutrino observatory on of its own or not? We'll see that also aspect and why it became controversial. In case if we are having where it is located, all these aspects will be looking into this particular video discussion. So first thing you need to know is what are neutrons. Okay, before that, yesterday why this was in news, because it was covered 2-3 days back in science section of the Hindu paper. Okay, they have covered in detail article about ice cube observatory. So why means, because in the landmark achievement, first time this ice cube neutrino observatory, which is based in Antarctica, they have identified ghost particles. So what are the ghost particles? What is meaning of the word ghost particles? We'll understand. Okay, so let's wait till then. So what we are discussing as part of this discussion is why in use, what about this observatory, what is its significance, what have they discovered significantly as part of the discovery and observations, what are the collaborative efforts involved in this observatory and funding, from where they're getting this funding and all. We'll know the fundamental aspects of neutrinos, properties of neutrinos, and Indian Neutrino Observatory, where it was located and what is its level of functioning. So who started this neutrino observatory, why there is opposition to this, all these other aspects we'll know. At the end, we'll look into what are all global level neutrino observatories we have in different parts of the world. So these are going to be the points of discussion which we are going to discuss as part of today's video. So here you can see this forms part under GS paper 3 science and technology section, especially under awareness in various science and technology fields. First thing you need to know is it is becoming a major achievement because here for the first time, okay, so first evidence of ghost particles were identified by this ice cube neutrino observatory. This was not established recently only. From long we have this same ice cube neutrino observatory based in Antarctica, but in recent times only they have found the evidence of ghost particles. What is meaning of the word ghost particles? Normally when you watch horror films, if you have the habit of watching horror films, so you'll understand that ghost can easily pass through any human body, without we knowing. That is what we observe, in the horror movies, and also easily they can take control over human body, and they can whatever they want to do, they can do that through that human body, right? The same way, why these are called as ghost particles, what are the ghost particles you're referring here is neutrinos itself. Okay, neutrons are different, neutrinos are different. I'll explain. Neutrinos are considered as ghost particles. Why we are considering them ghost? Because of their small size and less weight. Okay, almost zero you can say. Because of that, they can easily pass through any body. Even that body, like even when we are sitting and standing, or when we are talking also, many neutrinos may pass through our human body and we don't know also. That is why, because of their presence and their faster transmission from human body, or they can easily move from one body to another, for these reasons are considered as ghost particles. Okay, so first time we have identified in the field of astrophysical neutrinos we call. Okay, so in neutrinos we have again different types of neutrinos. For that to understand, you need to know some basic concepts. Okay, so very very important topic. Already UPSC have asked a question on this particular field, but as for the first time, okay, first evidence was discovered in this year coming prelims, or in the upcoming any state exams also, they may ask based on this particular observatory related questions. So first thing, the most fundamental fundamental particle we have is atom. No? In the atom we have nucleus, right? In the nucleus we have two elements, subatomic particles we call. Those are protons. Protons means positively charged. Okay, these are positively charged. And you have neutrons. Okay, these are neutrinos. These are different. Neutrons are neutral charged, and Around this atom there will be like in an air or atmosphere surrounding in which there will be electrons. Electrons are negatively charged particles like this. These are the fundamental subatomic particles which we have in existence. Okay, so what are these neutrinos, what we are referring, how they are different means these are also the tiny elementary particles only. They have very less small mass, very small mass, you can say. Okay, they have very small mass and they have no charge at all. No charge, like neutrons only. They don't have any charge and they're not part of the atom. Do remember, they are not subatomic particles. They're not part of any atom. This is the most fundamental thing you can remember, because UPSC, in case if they frame a question, they can say these are part of subatomic particles or something. So they're not part of atom. Neutrinos are not related to atom. Do remember this. They interact very little with the matter around them. That is why we don't even feel when they pass through us. We don't even feel that sensation or something. Okay, so this neutrinos cannot be attracted by magnets also because of neutral charge. So if there is some charge, there will be some attraction, but because of neutral or no charge, they cannot be even attracted by magnets. Okay, so why we have to study about these neutrinos, why they're important, is what we are going to discuss now. So these neutrinos, they have their origins from different things, like from sun. If some neutrinos are produced, okay, so that type of neutrinos we call as solar neutrinos, and some neutrinos may take their birth from other stars like sun. So those also, because here whatever the neutrinos are take part from the sun or other star systems, you can say those are low energy neutrinos, you can call. But some neutrinos are taking their origins from high energy processes like cosmic rays. So cosmic rays, and these are high energy processes. From there, if they are taking their origins, those we call as astrophysical neutrinos or atmospheric neutrinos. So those type of neutrinos only were identified for the first time using this ice cube neutrino observatory in the recent past. That is why it is in news. Okay, so I hope you understood this now. We'll have more clarity as we proceed further. Let's understand what is the importance of this discovery. Okay, so if you understand, most of the energetic phenomenon in the universe which is originating deep in the universe and all, that is very difficult to capture. Okay, so and it is very significant if we understand the pulse or what is happening and how these galaxies, you don't know, like even if we are part of the Milky Way galaxy, in which one of the galaxy we have in the universe, even that also we don't know how our galaxy is formed or how the universe formed, all these things. Just now we are thinking that some Big Bang theory or Big Bang explosion happened. All these are the things which we are believing, and we are not sure about how it happened and what all happened in the process. So this is what you need to know. So in case if you understand the neutrinos, from where they're generated, because one of the source of neutrinos is this cosmic rays, no? Astrophysical neutrinos we call. In case if we can decode them and if we can understand in what phenomenon they're getting generated, then we can get a better insights about the origin of the universe, right? That is why there are some parts of the, in some parts of the world we have some observatories specifically catered to study about the neutrinos. Okay, so to understand what is the origin of the universe, how the galaxies are formed, how this cosmic rays are getting generated, what is the high energy that is involved in generation of these cosmic rays or astrophysical sources, all these things. Okay, so we are trying to decode these things, or we are trying to understand these things as part of our explorations. Okay, so now first thing you need to know is, in neutrinos there are again some different types of neutrinos, like electron neutrinos we have, or tau neutrinos we have, muon neutrinos we have. We'll understand that also. I'll give explanation regarding those types of also. But first thing you need to remember is these are very rarest neutrino flavors or types we can call, because they give very unique information about the astrophysical sources. Okay, so tau neutrinos normally give the information about the cosmic rays, how they're being generated, what is the source of their origin, all these things. That is why for the first time, with respect to astrophysical sources only, we got some information and we detected the ghost particles responsible or which got generated from these astrophysical sources through this ice cube neutrino observatory. Okay, so this will enhance our knowledge with respect to our cosmic accelerators and understanding the gamma rays burst and all which is happening in the universe. At the same time, they serve as cosmic messengers, means they give some information to us with respect to universe origins, how the galaxies are formed, how universe is expanding, so what is causing these factors and all. So these things will understand right from the tau neutrinos, which are the major discovery of this particular process. So this universe is all connected with high energy process, how these things are happening, what is the source of energy, all these things will be better understood when we decode the process about this tau neutrinos. Okay, then what is this observatory? This observatory is located at India's, Earth's south pole, or you can say in the Antarctica region. And do remember that it wants to detect about the neutrinos. Again, in neutrinos, we have different types of neutrinos, but mainly they're focusing on the tau neutrinos. Here, which organization or which university have established means you can see University of Wisconsin in Madison of Antarctica. So mainly that was located there, and they're collaborating with these universities and many other universities, and they're trying to decode about this neutrinos. And do remember, this is the world's biggest neutrino telescope also. Okay, very important fact you need to know in case if any question has to be framed, they can ask about this specific fact also. Then collaboration and founding, and already I told you, it is supervised by University of Wisconsin in Madison, and IceCube is collaborated, and it is established in 2005 itself. Later on, it started its completion and it started its operations right from 2010 onwards. And many other universities right from other parts of the world are also helping in this research. So what you have to know about neutrinos? Neutrinos are, as I told you, tiny elementary particles that exist in a large scale in the universe. They're so much available, abundant, you can say, most abundant elements, and but very small in size. Okay, so they're very small and they don't have any charge. Do remember this basic fact. And they're not part of atom. That is what I told you already. And they interact very little with the matter around them. That is why, because of neutral charge, even they don't get attracted to any magnet and other things. Okay, so this will help us in understanding the origin of our universe, what happened in Big Bang, so how universe formed and all these things. Okay, so if you see where from where we have these neutrinos means origins, like I told you, sun or stars we have, or explosion of stars also is one of the factor that has led to this neutrinos creation, or even this other radioactive decay, other factors like radioactive decay. And we have other process like gamma ray burst. All these things have created these neutrinos. Okay, so from where there they have their origins. This is what the origin of neutrinos specifically you need to remember. And they can even be produced by man also, in laboratories also they can be produced. And do remember, we have four fundamental forces in the universe, no? Like we have electromagnetic force, gravitational force, strong nuclear force, and weak nuclear force. So normally these neutrinos doesn't show their characteristics or they doesn't interact with any of the forces except with weak nuclear force. Only in weak nuclear force only they show their interactions too. That is another important fact you need to remember. And they form part of lepton family. Lepton family means it is consisting of electrons as well as this neutrinos. Only here you have to remember, electrons and neutrinos together they belong to the lepton family, because lepton family means which are the particles that form part of weak nuclear force, or which interact with nuclear force, weak nuclear force. Those will be considered as lepton family. Here we have only electrons and neutrinos. So do remember these two things. And it was first identified by Wolfgang Pauli in 1930. So he found it in an experimentation set. In 1956, it came out to the particle physics and other parts of the science related observatories in astrophysics. Then what are the things you have to remember? These type of static questions also can be asked. Okay, so electrically neutral, tiny mass, I told you, weak interactions, only with weak nuclear force they will interact. And speed, if you see, almost the same to the speed of light. We have most abundant particles. Okay, so they're very huge in number. And you can see cosmic messengers, that is why they carry information related to the distant sources also. So we can understand, right, everything related to Big Bang, origin of the universe and all. So that is why this neutrino study is very important for us. Okay, then what are the types of neutrinos here to understand means electron neutrons. Electron neutrons are nothing but, here these are the neutrons which will interact with the electrons. Okay, so that will be considered as electron neutrinos. Then you have muon neutrinos. These are nothing but, these will be interacting with the cosmic related things, cosmic rays, gamma ray bursts. Those are called as muon neutrons. Then tau neutrons are there. No, these will be involved, or these will be coming out of astrophysical sources or high energy processes. So those type of things we call as tau neutrons or high energy processes. Okay, so these are the three basic types we have, or three flavors also in neutrinos. And another term you have to remember is neutrino oscillation. So neutrino oscillation is also one term which you maybe which can be asked in examination. So neutrino oscillation is nothing but we have these three types of flavors. In case if one neutrino of one particular flavor is changing its characteristics and is turning into another flavor neutrino, then the term we call it as neutrino oscillation. Means from one particular flavor to another particular flavor, if it is changing its characteristics, then we call it as neutrino oscillation. Okay, these are the things which you need to know. Then coming to Indian context, we have an Indian Neutrino Observatory, INO. Where it was located means it is located in Thene district of Tamil Nadu. But this project was not functional now. Why? Because it didn't start it also. Because although it was established, okay, underground observatory. Why underground means to minimize the radiation impact. Because when we are studying about these particles, there can be a chance of radiation. No? So if you're located on the ground, so then there can be dangerous impact on the health of the human beings and the surrounding flora and fauna. No? That is why these such laboratories will be established most of the times at a distance places from the human habitations or underground. So in India, it is underground laboratory, mainly again to study about the neutrinos only. Again, it is located in Theni district of Tamil Nadu, almost 100 kilometers from Madurai. You know, Madurai Meenakshi temple we have, no? From there, almost 100 kilometers only, we have this neutrino observatory located. So here, who are establishing this in India? Who have established means jointly funded by Department of Atomic Energy and Department of Science and Technology together, along with Tata Institute of Fundamental Research. We have Mumbai. This is also collaborating, and this is helping these two departments in more studying about the neutrinos. This is actually envisioned. Then what happened to study about the neutrinos? This was established. Purpose to understand the physics of little understood particles, because there is no much research about these neutrinos. Now to understand from Indian part, okay, we are trying to this and INO and to detect the masses of the neutrons and neutrinos, I mean, and also to understand about the evolution of the universe and to study about the core of the earth also. So because of the core of the earth, it is also from the origin of the universe only, so core, then we have mantle and crust, so developed. So what have created these things? If we understand neutrinos, then we may get some insights related to these things. That is why we have established INO. Then what happened actually means, as it was located in a very environmentally sensitive area. If you know Tamil Nadu, they are in a place where this Western Ghats and Eastern Ghats meets an ecologically sensitive area. And this body West Hills are also very ecologically sensitive area. So when it was conceived in 2005, initially they didn't get even environmental clearances also. It took a very long period because it is located in sensitive tiger corridor, Periyar Tiger Reserve we have, and we have Manikuttan Shola National Park also. It is located nearby only. So because of the dangerous impact of this neutrino observatory, so many environmentalists have opposed to this observatories planning and all. So they didn't allow, and they have pressurized the government not to give permission for this INO. In that way, it got stalled for some time. Later on, what happened? National Tiger Conservation Authority, we have no statutory body mainly interested to look into Project Tiger. No, so this body also gave clearances. Then what happened subsequently? 2 years back or 3 years back, Tamil Nadu state government itself said we are not allowing this INO to be established or to function from our particular land because of dangerous impact on the environment. So it didn't start it. Okay, so we didn't have this INO functioning in India. Okay, although it was conceived and it was established there, almost an important thing you need to remember is it is almost underground only. That means 1200 meters deep from the surface only. That means almost 1.2 kilometer if you go deep, there it was located, but still environmentalists are not agreeing. So in this topics, when we are coming across, there will always be a debate with respect to environment versus development. So if you're watching this and if you have your perspective which has to be protected more, either environment should be given more weightage or development in these things is very important. What is your opinion? Try to give in the comment section. Okay, so here now, as of now, this project was not commenced, and we'll understand about other global neutrino observatories. Here we have is Stadbury in Kerala, we have then Super Komio Konde we have in Japan, Gran Sasso Mountains Italy, Sound and Mines in USA, Katrin Experiment in Germany, we have Daya Bay Reactor Neutrino Observatory in Hong Kong, and Ice Cube Neutrino Observatory, that is in Antarctica. In this way, we have these global neutrino observatories located in different parts of the world. Along with we have India National Neutrino Observatory located in Tamil Nadu, Thane district. Okay, so this can be also asked in coming exams. So you be thorough with these things. Okay, so now we'll see the practice question given yesterday. In the cities of our country, which of the following atmospheric gases are normally considered in calculating the value for air quality index? Yesterday we discussed about World Air Quality Report. No, so in that what forms part of AQI? So we have discussed in detail. It is not carbon dioxide, but carbon monoxide, nitrogen oxide, sulfur dioxide, and there is no methane. Okay, there are 8 gases. I have explained in that. In case if you didn't watch that video, you can watch in the channel itself. So what is the answer here? 2, 3, 4 is the answer for this question. Okay, option B, 2, 3, 4. Then time to test our knowledge on based on today's discussion. In the context of scientific research, consider the following statements about ice cube. A particle detector located at southern pole, which has been recently in use. It is the world's largest neutrino detector encompassing a cubic kilometer of ice. It is a powerful telescope to search dark matter. It is buried deep in the ice. Okay, so what are the related aspects? You answer in the comment section based on the statements given. Now let's see the mains question. Tau neutrinos serves as cosmic messengers carrying the information about the catalytic events and also the cosmic ray interactions. Comment. So that was a question asked. Try to answer in the comment section if you can. Then as we have come to the end of the video, today we have discussed about ice cube neutrino observatory. What are ghost particles we have seen, what are neutrinos and their characteristics we have seen. At the same time we have seen global neutrino observatories and Indian National Neutrino Observatory. Where is it located, why it was opposed, and why it couldn't function. All these aspects we have discussed as part of this video. Thank you for watching. Have a good day.